Okay, so lab 43 involves dropping a ping pong ball, a basketball, or a football. So what we're going to do is we're going to take a look at this lab here. And here we have a certain height. Okay, the ball's here, and here's a ball. And suppose if I drop it from right here, what's my starting height? I'm holding my breath. 1 meter. Okay, so I'm going to drop it. Now, if the ball bounces and it goes all the way back, so when it's here, it's all potential energy, right? As it drops, what's it being converted into? Kinetic. So at the very bottom, what's the energy here? Kinetic, right? Now, when it bounces back up, hopefully all the kinetic energy is being transferred back to potential, so it should rise back to the top, okay? That's if there was no loss of energy to heat. So if I'm here and I drop it, we can see here that on each subsequent bounce, it gets smaller, smaller, and smaller, right? Okay, so what happened was, in this particular problem, we started from rest, right? So this was 0 at the top, right? Okay, and we're going to, for right now, we're going to ignore friction for right now. Okay, when it hits the bottom, what is it? It's all kinetic, right? Okay, but when it hits the ground and comes back to the top, what's the kinetic energy? On its way up at the top. So anyways, what's the potential energy here? It's all 100%? Okay, so it comes here, what's it right here? All kinetic? Now when it comes back to, let's say it stops right here, is it all potential?
Yeah.
Yeah, I mean, well, yeah, it stops, so it's not moving. So when it's not moving, is potential energy here. Right? Okay, so that's what's happening in the bounce here. So that means that, here's our meter stick here. Okay. The ball starts here, it comes here, it hits the ground, and then it bounces back up. Let's say it stops here. Okay. It goes to this position right here. Okay. So here, the kinetic energy here is 0. It hits here, it comes back, it stops here. What's the kinetic energy here when it stops? It's not moving. 0. Okay, so 0. So in our formula here, we have starting potential energy. It hits the ground, it comes to this position here. Kinetic energy is 0. So this is also 0 as well. So what happens is that we have potential energy initial equals the final potential energy. Okay? Now, what does this mean? This means mgho. HO is your starting height, which is right here. Okay? It comes down, hits the ground, it comes back up here. This position here is our final height here. This will equal mgh, like that. Right? Okay? Now, so what's going to happen is that, are these going to be equal to each other? So, is there, when it bounces up, is there some loss to heat? Yeah, so when it bounces, if you hear noise or you hear any deformation of the ball, that means energy is being lost to heat. So, for example, if the ball goes to the top, then it'll equal each other. But if it comes to this high, is it going to be the same? So this is not going to be equal to each other, right? So that means that in reality, this is mgho is going to equal mgh plus heat loss, or we'll say heat, or friction. Okay. Now, those two will be equal to each other. So, for example, if this was 10 joules here, it bounces, comes up to here, and this is, let's say, 6 joules, they don't equal each other, right? So that means how much was lost as heat? 4 joules will be lost as heat, as an example. Okay, so this will be the, so for this lab here, what you're going to do is you're going to, in the simulation here, you're going to be dropping the ball from different heights, and they have a virtual iPhone that measures this, and basically you're going to, ultimately, you're going to record potential energy starting, final potential energy. You should get, now, if these two are equal to each other, you should get a straight line like this, okay, a slope. Now, however, in reality, in laboratory, you'll probably get something like this in reality. So what you do is, this will have a slope of 1. Whatever this slope is here, you take 1 minus this slope, and that will get you the percent lost as heat. So that will be the basis of this lab, for lab number 43. Okay, let's stop.